Hey guys, so I'm just going to walk through a practice dilution problem with you guys, a backwards dilution problem, so that hopefully we can all get an idea of how to do these. So you might do them differently, everyone might do them a little differently, but the best way to check that you did it right would just be to calculate the way we usually do and go from there. So let's start off by just saying, okay, we have culture, we'll call it culture Z. Okay, and we'll say has a titer of, why is my eraser so big? Okay, has a titer of, we'll do 6.4 times 10 to the 7th bacteria per mil. Okay, and so what I'm going to start with is just by drawing out a little cute dilution scheme. So this is going to be my culture Z. And then we would have a bottle, like 3 of them probably. And you can do this differently and have different amounts of bottles depending on how much you're moving. And so I'm just going to put each of these as 99 mils. Make sure you're labeling how much is in them, or else we don't know. So this is going to be B1, B2, B3. And we'll just do how we always do, where we're just taking from the first one, adding to there. And so I'm just going to do 1 mil, 1 mil, and maybe 11 mils. We can try that first. And then we'll go on to 3 plates. And I'm just going to be doing the 0.1 mils onto them like we usually do. Okay, so then we're looking at this and we want to see if this actually works, right? So then we will just go ahead and we will kind of do the opposite of what we usually do for these. So I'm going to start by doing CZ, VZ, that's just our culture, equals C1V1. So to set this up, we know the concentration of CZ because it's given in the problem. So we're just going to do 6.4 times 10 to the 7th bacteria per mils. And then the volume of Z, we're doing the volume taken. So that's what this first V will be. So we're just going to be doing 1 mil, and then we'll do equals. We're looking for the concentration of bottle 1, and we will do the total volume of bottle 1. So that's going to be the 99 plus the 1 mil that's coming in from the original culture. And so we will put 100 mils for this. Okay? So then we will divide this over. And let's calculate that really quick. If we have 6.4 times 10 to the 7th, we're just times 1. And then dividing by 100. And now I'm getting the concentration of bottle 1 as 6.4 times 10 to the 5th bacteria or cells or CFU per mil. Let's double check that. 1, 2, 3, 4, 5. Yep, cool. Okay, so then we can move on to C1V1 equals C2V2. And so just the same way as above, we're going to put in the 6.4 times 10 to the 5th cells per mil, the volume taken out of bottle 1, which is just 1 mil, equals C2 is what we're looking for, and then volume 2 is just going to be the total volume of bottle 2, so that's going to be 100 mils. Okay, and so then we do the same thing, divide this over, and for that 100, we are going to get C2 equals 6.4 times 10 to the 3. 1, 2, 3. Yep, okay. So, sorry guys, it got so dark. So now looking at this, maybe we could just stop here, right? But then we could see that that wouldn't really work when we're trying to get within 30 to 300 colonies. So we will do it one more time. We'll do C2 V2 equals C3 V3. So we're just going to plug in that number we just calculated, 6.4 times 10 to the third. Then we'll do the volume taken out of bottle 2, which here it's going to be 11 mils. Okay, and then that is equal to the concentration of bottle 3 times the total volume of bottle 3, which for here is going to be 110, since we were moving 11 this time. So let's multiply by 11 and divide by 110. Okay, so that gives me the concentration of bottle 3 is equal to 640. Okay, so now this is where this can get kind of tough, because we have to remember where this number 640 is actually coming from. So we have to think about when we're doing the I guess it's the forwards version of this, where we start from the plates and go to the culture. And so this number is calculated, this cells per mil number is going to be calculated by doing the average cells on the plate, the average plate count, over 0.1 mils, because if that's what we're going to move. Okay, so we don't have to move this. So let's see if this works moving 0.1 mils. So to do this, we would be setting this equal to the average cells on the plate over 0.1 mils. And so we'd be multiplying that over times 0.1. Okay. And so this gives us 64 cells per mil. Sorry, that's just going to be giving us the average cells. My bad. So that's our average plate count, and that fits into our 30 to 300 that we're looking for. So then we can see that, okay, this works with these numbers up here, with these specific numbers that we're taking. We can see that we could get to where we're having an average plate count of 64. Okay, hope that helped. Shoot me an email or Bella if you're still needing some more help with this, and we can go over it.